Good morning, good afternoon, and good evening, wherever you are. And welcome to day 7 of our 12 days Geospatial Python Bootcamp. Today, we will introduce ourselves to Rasterio or Rasterio, whichever way you pronounce it. And that means we are also starting to learn how to work with raster datasets in Python. Okay, so we shall take a look at our agenda for the day. We will introduce ourselves to rasters in GIS and also to raster files in Python. Then we will look at how we will represent raster files in Python, and then an introduction to the Rasterio package. Okay, so what is a raster file? A raster is a spatial data model that represents the world as a grid of equally sized cells. And these cells are often called pixels or picture elements. And each of these cells or pixels in a raster holds a particular value, a single value representing the specific attribute. So if you have a raster file for temperature, each of the cells in that raster holds a value that represents the temperature at that particular point. Okay. So if it is an elevation also, the value there is elevation. If it is rainfall, whatever it is, that particular cell or pixel holds that value for that place. So if you have a raster pixel that covers, let's say, your house, that means if the raster file is a temperature raster file, the value that you have in that particular pixel is the temperature around your house. Okay. And rasters are also often used for continuous data, like satellite imagery and then digital elevation models and some weather models that we have, like CHEPS precipitation data. Usually want to use this raster to represent continuous data because it will be difficult to use the vector to do. The raster represents continuous data the best. And so some of the key characteristics of raster data we will look at is the resolution. When we talk about the resolution of the raster data, we are talking about the size of each cell or each pixel in the grid. And that also determines the spatial detail. So if I tell you that my raster file has a resolution of 10 meters, that means that each cell, each pixel is 10 meters by 10 meters. Or it represents 10 meters by 10 meters on the ground. So if I tell you that I have a raster file and it has a resolution of 30 meters, it means that when you pick a single cell, a single pixel in my raster data, it represents 30 meters by 30 meters on the ground. Okay. And we also have something called the extent of the raster, which is the spatial boundary of the raster. So that is the coordinate of the edges of the raster. So if it happens to be in a perfect square shape, that means the coordinates of all those extents, the corners of the raster. And then also one thing that you should note is the band. Rasters often come in bands, or we call them as bands. Think of a single band. We will get to know what it is, but usually, should I say that non-technically, I would say a layer, maybe, but usually they are in bands. It can be a single band or a multi-band, where it is a multi-band, either a composite or a way that multiple bands has been stacked together that you can separate into individual bands. So, for example, if you have what you call an RGB image, that image or raster data has 3 bands: red, green, and blue bands. And each of these correspond to a particular color channel. Okay. So if you take, for instance, the Landsat band, if you go to the website, they have a configuration for each of their satellites. So you get to know which one is red, which one is blue, which one is shortwave infrared, and all the other ones. Okay. Rasters also have a coordinate reference system. Of course, they should have And that is how we can even position them in a real world, a geographic space in any software or programming language which is able to handle raster data. And rasters also have data types, and those ones usually is the format of the cell values. So we have integer raster and floats. And so if it is an integer raster, that it means that the value of the pixels are integers. They are whole numbers. And then if it's a float raster, it means that the value of the pixels are floats. When we say float, numbers with decimal points or decimal places, so you usually see the number, then a decimal point and some numbers after the decimal point. Okay. So this is a raster data. You can see on the image at the left, there is a real world down here. You see some grounds and some forest. There is some kind of marsh, and then there is a water body, a lake here. Vector representation will be like this, because with vector we can draw very smooth and accurate shapes. If you want to represent areas like that, you do that accurately with vectors than you do with raster. And you can see the raster representation at the top there. It is using those boxes, or what we will call grid. Those are the pixels of the raster. So that is how a raster data set looks like. Okay, and so inside those boxes is what you have. Those are the places where you have those numbers, digital numbers, that corresponds to the particular phenomena that the raster is representing. So for this particular case, maybe all the waters will have the water pixels will have values in a particular range. Let's say maybe from 5 to 10. So if you click on any of them and you see something between 5 and 10, then you know that you have clicked on water. And then the forests to have a particular range of pixel values and all the other phenomena that they are representing. Okay, to the right also is another representation. References to all the images have been given down there. And so you see that this one too, they have actually kind of manually drawn the grid on the raster data. It is possible. This is just a representation, I'm sure, because usually for this looks more like a drone imagery. So usually those images come with finer resolutions than the boxes are representing. But they are just trying to show that on the right, far right, where they have the grayscale or the black and white representation, that those are the ways that raster values can look like. Okay. And so examples of raster data, we have a lot of them, but let me just put these two here as an example. We have what we call the digital elevation models, and they are used to represent elevation. And then we have satellite imagery. There are others like precipitation, like a lot. The ones from chirps, they are just a lot of data. So let us also look at how we will represent raster files in Python. In Python, geospatial raster data can be manipulated with libraries like Rasterio, we have GDAL, we have XArray, and then real XArray. I don't know how you pronounce it, but that's how I choose to pronounce it. There are others too, like scikit-image and OpenCV. The list is not, it continues, but I think these are the popular ones that you like to explore. Rasterio, we saw it the other time during the onboarding. GDAL also, I think. But this XArray is a very powerful library for handling multi-dimensional data sets. And if there is also the raster, the version that incorporates Rasterio, and then the capabilities of the XArray library. So that's what we call it, real. Maybe I don't know how you pronounce it. Maybe Rose Array or Real XArray, however you pronounce it. But this is the name there. So just like GeoPandas added geospatial um, analysis or capabilities to the pandas. I think it's the same way that Rio XArray has those geospatial capabilities to the XArray library. And there is also scikit image. I think mostly if you want to handle or maybe machine learning stuff like some complex detection and other stuff, you may want to use the scikit image a lot. I think these four here are more like analysis. Like they are really able to handle the raster data in terms of the numbers, because at the end of the day, the raster is just, you think of it like a big matrix, just a big matrix. So you just know how to manipulate the numbers. Okay, and there's also the open source computer vision library, which is also very powerful for handling images. And so these libraries will allow us to create, read, write, and manipulate our raster data sets. Okay, now to the package for the day. Rasterio is the go-to library for handling raster data. In fact, if you want to handle raster data in Python, or if you ever try to do that, then when you search for help on the internet, most likely the results will contain Rasterio, because it provides a fast and easy to use functionality to read and write your raster data, like the popular GeoTIFF format. You can perform some common operations also, like clipping, reprojecting, resampling, merging, and all that. And it integrates seamlessly with NumPy. NumPy is also a Python package which is very powerful for handling. It does well with like computations, heavy mathematical computations. So in the case where we look at the image or the raster as only a grid of numbers, this NumPy comes in very, very powerfully. I think we've used it before, not so much. I think it was yesterday and some other days we used it to generate random numbers, but you'll find out soon that it does far, far more than that. So once you also know some NumPy, matrix multiplications and other stuff, you don't have to know NumPy in detail to use Rasterio. Of course, that's why we are doing this bootcamp. And it will not be a NumPy tutorial, but at least you get to know one or few things that you can perform on NumPy arrays. Because at the end of the day, it reads it and it treats it like a NumPy array. So that makes it very, very convenient and possible and easy and very, very smooth to do pixel level manipulations and calculations. Okay, I think that should be the end of our slide. So let's see. Okay, yes. So let us go into VS Code and then see how we can work with raster dataset. Okay. So let me go to full screen. And let's first get a raster dataset. So open your browser. We want to get a digital elevation model. I think those ones are really not heavy. So just type open topography. This is the site that I usually download my DEM. So you search for open topography. This one. And then you click on this first link that says opentopography.org. Whilst this one is also loading, let me open QGIS in the background, because today we'll be using QGIS too. Okay, so this is the website. If you come here, just okay, QGIS, we'll come back to you a bit later on. When you come to the website, what I want you to do is to come to this nav bar, go to the data, and go to the find data map. Did I select it? Yes, I did. Okay. So this is the data map. And what I want you to do is to come to the left side here, the right side here, sorry, and uncheck all these layers. We don't need them. And leave the global and regional DEMs. Leave that one there. And then click on select a data set. Let me zoom down a bit. Let's scroll down, sorry, a bit. And then the USGS, depending on where you are, you might get the USGS 1 meter. I think it should be available only in some places in the US, and the 10 meters also. But apart from that, maybe if you're not in the US, let me see. When you click on it, usually it will show on the map. So you see that the USGS 1 meter is available in the US. And this place also, which place is this? Okay, so it's just for the US. And so if you check the 10 meters also, that's also for the US. And then 30 meters, I think 30 meters should cover most of the other places also. Okay, I think I've zoomed into the browser a lot. So what I would like you to select is the GL1 and GL3. That one covers the whole world. So once that is selected, if you're also in those places with the final resolution, you can select that one. That is also great. If you look at the top left side of the map, you see select a region. So click on it. And then what we do is to zoom in and select a particular region where you want to download our DEM. So I'll zoom into the famous lake description. You can select it for your area. And this is also a very good place for the study because this is the lake basin, and then you can see the elevation by the shadows. So let's say I draw a place like this. Please be mindful of the area you draw, because the larger the size, the larger your data will also be. Once you select a region, it will bring you through this page like this. Come down here to you see the Shuttle Radar Topography Mission, SRTM Global. They provide global elevation data. And then there's the GL1 and the GL3. One of them is 30, one of them is 90. So the GL1 is 30 meters resolution, and the GL3 is 90 meters resolution. So we want a final resolution. I explained resolution earlier. So we want the final resolution, which is the 30. So what you do is to click on the GL1. Once you click on it, it will bring you to the GL1 page. The region is already selected for us, so we don't have to worry ourselves. And here you can choose the format that we want to download the data in, whether GeoTIFF or IMG, imagine file, ADAS imagine file, or ASCII. That one too. ArcGIS can handle those ones. I think Python 2 should be able to handle it because net CDF files and all, it can be handled in Python. So here, if you want to add any other things to your DEM, you can add it. You want a slope, you can add it and all those files. But I'm not selecting anything to add to it. But one thing is that you have to give a description why you are downloading their image also. So here I will say my title is a geospatial analyst, and then description, using this data for tutorials, and then my email address. So I provide my email address. And then I just submit it. Once I submit, it will verify, and then it will, when the verification is done, they will give me the link to download the data. Okay. So once that one is ongoing, let me come back to, okay, I think it is done. Okay, it is done. So this is the link to download my data. So I click on it, and the download should initialize. Try again. Okay, it is done. So I'll come here. Okay, it's actually not done. Okay, it's not done. I'll come here. Where's the file? I'll right click, cut it, come to where I have my folder, day 7, create a data folder, and then inside the data folder, I will paste it in, and then I will extract. Okay, I don't want it inside this folder. Let me rename it to DEM, and then let me even rename the file inside to dem.tif also, just so that it will make things easier. Okay, so now this is our DEM. I can bring up QGIS, and then drag and drop it into it. So this is our image of the lake. You can see it here. So this was a selection I made. Now, if I change this into the identifier and I click on any pixel, you should see that I have, okay, it's difficult. The other time I said I'll do it and I did not do it. Please forgive me. But I have to find a way of, okay, that was fast. Is it about the downloading of the image? Should I repeat the process? Please let me know if I should repeat the process for the downloading of the image. But this is the DEM. If I click on, okay, let me zoom in for you to see what we call the pixels. I don't know whether it to show on your screen, but you should see some boxes. There are some boxes. Let me get to more white. Okay. Perfect grounds in between black and white. Okay, maybe this place will do. But I think you should start seeing some boxes. Those are the pixels. And so if I click on any of them, I get a band value here and also the coordinates that was clicked. So each value I click, each box I click gives me a different value. Okay. Okay, I'll go over the download process again. So you come to your favorite search engine and you search for open topography. When you search for open topography, look at the first link that says opentopography.org. And then you click on that link. It will take you to the open topography homepage. When you come here, go to data at the navbar and then click on find data map. Then it will bring you to this map. Find data map will bring you to this map. You can download other data sets here, but we are interested in the DEM, the digital elevation model. So I will uncheck all of these other layers with the exception of the global and regional DEMs. And then I want to select a particular DEM to download. There is the Copernicus 30 and 90 meters. There is the one from SRTM and other providers in here. And some of them I don't know about them, but maybe you do. So whichever one that you prefer, you select it. But not all of them are available for all regions. So that is why I think the Copernicus should be available for the whole world. Those who have 30 and 90. And the SRTM2 is available for the whole world. But the USGS 1 meter resolution, the finance one, is only available in the United States. And I think the 10 meters also. So what I went for is the SRTM, GL1 and GL3. Once you have it like this, what you do is to come to the top left of the map, and then you can click on this button that says select a region. Once you click on it, your cursor will change to this plus, or yes, it's a plus. And then you zoom into any place of your choice, most probably your area, and then you draw a bounding box. So if you want to download it for this particular area here, you just click, you just click and drag until you cover the whole area. As you click and drag, you can be using the mouse wheel to zoom in and out. So you just click and drag until you have that area that you want. So I have selected that particular area. As soon as you release your mouse, it will scroll you down to this place where you select the data type. Once again, we are going with the Shuttle Radar Topography Mission, DEM data. And then the GL3 is a 90-meter resolution data. And the GL1 is a 30-meter resolution data. So of course, we'll go for the final resolution, which is 30. So once you click on this, it takes you also to this page. And then you scroll down. If you want to reselect the region, you can do that. If you, other than that, you just have to scroll down. And then you select your data format, whether ASCII, GeoTIFF, or image, or the imaging file. And then if you want other visualization types too, you can check them over here. And after that, the last step to download your data is to provide your title, give a description on how you are going to use the data, and then your email address. Okay. So when you are done, then you submit it. Once you submit it, it will take you to a page where it will process your details and then your request, and then it will give you the link to download it when it is done. So you just click on that link and then you download it when it is done. You can also check your mail. They will give you a message to download it when the verification is done. Okay. I hope this time around you got it. I will appreciate your feedback if the second one was better. Okay, does it allow my shape file? Let's go back and see. So, okay, let me reset. If you keep your mouse on the map, once you want to scroll down, you'll be rather zooming in. But I've not really explored uploading a data set here as the boundary. But I don't think I've not explored it before, but I don't know. I can't really tell whether it will allow you to do that. I can't tell. So you can explore the website to see. Okay, so it looks like everybody is okay. So this is the raster data. Okay, so if we right click now and I go to properties, go to information, I see a lot of stuff here, which I wish I can zoom in for you to see. But when you open it on your own, you will see it. That the provider is GDAL. Okay. And this is the extent. I was telling you some properties of the raster. And see the width, the height, the data type. I was telling you that it's either an integer or float. And I think there are other types too. But this is a 16-bit signed integer. That means that, okay, signed and unsigned. Let me see. I have the definition in mind, but I'm a bit confused on how to express it. So signed and unsigned integers. I came across them when I was doing my C++ and learning C++. Okay, so the signed takes the negative into consideration. So in signed, the whether it is negative or positive matters. And that one, the range of numbers of this one is a 32-bit. So I think that one said that is 62 bits. Okay, 16 bits unsigned integer. So let me just say 16 bits. Hey, not 116, 16. Okay, so 16 bit unsigned integer ranges from 0 to 65535. That means that the values in the raster should be within this range. If it is unsigned, that means that there cannot be negative value. But if it is a signed integer, that means that there can be negative values, and that range of numbers or that data type has a range of minus 32,000 to plus 32,000. So it cannot really represent values which are above plus, okay, in this case, plus 32,776. I was just trying to keep it simple. So any value above this, you cannot really use a 16-bit signed integer to represent it. But in the case where there are no zeros in the raster values, unsigned with the same bit can represent it. So that is it about the data type being signed. This one is signed. Okay. And the type is Jtive and other stuff too that we can find here. And I think if you come down, you also see our coordinate reference system. I'm looking for the bands. So there's only one band in this particular raster data. I think we will have to explore how to access data sets which also have multiple bands so that you see it. Okay, so enough of looking at, I was trying to see if I would see the transformation. Okay, so that is not here, but we view it with Python. Okay, but we will leave our image open here like this because we will have to come back to it from time to time. Okay. So now let's look at an introduction to Rasterio. So the first one we look at, of course, is opening, how to open a raster file. So opening a raster. file. Let me select my kernel. And then here we import Rasterio. Usually, by convention, people import it as real. Fine. So let me first run it and see whether I will get any issues. Okay, I did not get any issues. But I think another thing that I should do is to open the Rasterio documentation. Rasterio docs. Okay, so this is the Rasterio documentation. We were here during the onboarding and we are here again. Okay. So I think this example extracts GeoJSON shapes from a raster. Okay. This is a way advanced for where we are now. But if we go to the Python quick start, I think so. And opening data sets. See, there's a guide here on how to. I think this documentation in particular is it's a bit friendlier. So all that we have to do is to say rasterio.open and then we open the data set. That is all. So let's come to Python and see how that one is done. The documentation is saying that we can say that data set equal to real.open. Then we pass in the path here. I think that should be ./data/dm dot save. Documentation is saying that we can open it this way. And that is true, but it is not really the recommended way. No such file or directory. Oh, sorry. It's not /diff. Okay. No such file again. Don't I have it there? Oh, okay. Sorry. It's not in there like that. It's inside a folder called DM. Okay. Sorry. So there should be DM/another DM.save. Okay. Documentation is saying that we can open it this way. And there's nothing wrong with, actually, there is something wrong. There is something wrong. And that has to do with Python. We don't really talk about memory management, but it's something that kind of exists behind the scenes. Once I have opened this data set like this, I think VS Code should. Let me minimize my. Once I'm using Jupyter notebooks, I should see some things like the variables that, okay, fine, it is up here. Now, when I open these variables, I see that I have one variable here called data set. Of course, I open the variables from the top here. Called data set. It's a type of data reader, and I don't know why it's not giving me the size, but it has this value. This variable is existing somewhere in my memory. So if I finish using it and I forget to say, let me put a new code cell, dataset dot close. I will finish running my program, maybe close VS Code, close my notebook, but that file I've read most likely will still be existing inside my memory there. And now when I go to variables, I should not see anything because I have closed the file. But if I comment out this, run this again, and let's just try and run any other Python code that doesn't really do anything. So print hello. If run that one, this is also this one is how do you call it, a comment, so it will not have effect. And I come, okay, I don't know, maybe I have to restart the kernel. Let me see. Because this type of owning does not really have the capability of closing the file immediately when the usage is done. So now let me run everything again and see. Variables. And now you see that data set is here. So it is not closed from memory. Even though I'm far away from that line, I'm done using it. I only read it and I did not do anything to it, but it still exists in memory. So if you ever go through the documentation, I think this one you're just using it to test the waters or just introduce you to some concept. But if you want to properly open a file in Python, the most and best Pythonic way is to use the with keyword. What a with does is that if you exit that particular block of code, or if you finish it, it will close the file in memory, and then it will not cause any file integrity error if you have to open your file in another application or in another place. So this one, it will not be the regular with open. This with open is run from Python. You say with real.open, and then we have to pass in the path again. So that's with dot/data/dem/dem.tif. I think today I placed it in quite a far place. And then we can open it as maybe file, as raster. You can put anything here. But usually, by convention, it is SRC. And then once this is done, we can do whatever we want to now do with our raster. So let me delete this cell. I don't need them. Okay. So let us look at some of the few things that we can do with raster dataset that has been opened. Okay, so this has been read as SRC. If we want to read the data, okay, this has been opened. Or let's just say that the file has been opened. If we want to access the band in there, in that case, we read it into what we call a NumPy array. So read a specific band into a NumPy array. Okay, I know that rasters are kind of a bit difficult. I don't like to say it's difficult, but a bit detailed than vectors. So if at any point in the tutorial I have to go back on anything, just say, hey, Tommy, I did not really get this concept. What were you saying in this particular line? Explain yourself again. So that I want you to understand that is why we are doing this. So if you find it complex, just pause me at any point in the stream and say, hey, Tommy, go over that line again. I didn't get it. Okay. So how do we read a specific band? We can say band equal to, and then we checked. We saw that our data set already has one band. And how do we even see the number of bands in the data set? So we can say bands, okay, bands equal to src.count. This one will give us the number of bands. So if we print, let's say in an F string, and say that number of bands and then plug in bands. Okay. If I run this, see the number of bands is 1, just like we saw it in QGIS. So src.count, that means that we can only read the first band, we cannot read the second band. If we want to read a particular band, as I said, now we found out it's only 1, we go src.read. And then here, you can optionally pass in the band number. So if there are 3 bands, you can read the third band by passing 3. If there is only 1 band like this, you can leave it like that, or you can pass in 1. But it's always good to pass in this 1. It is always good to do so, because sometimes if you don't pass it in like this, these data sets, I said, they are in like form of matrices. Think of it that way. So there are dimensions to the data set, and so if you don't pass it in, it might read the whole of the SRC, and then the SRC will now become like an outer or a bigger list, which contain the list of bands. So this is what I'm trying to say. Let's say there's a bigger list for the SRC, which contain other, let's say, band 1, and then maybe another one, band 2, band 3, and those ones. So it is always important, please, if you are reading the first band, even if it's only one band in there, specify it so that you not end up reading this whole big band. In that case, if you want to perform some calculations, you might be in trouble because now you have to write complex indexing and selection algorithms down there. Maybe it will work for you, maybe it might not. I think it has given me a problem like that before. That is why I'm recommending that you do it this way. So now let's see what is inside this particular band. We can call it as always, and now we see that it's a numpy array. In fact, we can print band.type so that you see that okay, type of type and then band. You see that it has a class of numpy array. And okay, let me also print src. Just take a look at how the band looks like, or let me print it. I don't know whether the printing will display it like we are seeing it now. Let me see. Okay, it prints it. So let me print the src before the band. So print src. Okay, so it's only telling me that it's a dataset reader. That's the file name. And then, okay, so I can't really see in detail like that. It's just a Rasterio dataset reader object, and that is fine. Okay, but we see here some numbers. These numbers are starting from, now I'll come back to QGIS. This 269, let's try and locate it. Most likely it will start reading from the top left like this. So we are looking for the very first pixel in our data set, which will be very difficult, to be honest, to locate it. Very, very difficult. Oh, okay, I located it. It's 269 here. Okay, I think most of the stuff there, oh, I've zoomed in too much. But that 269 is starting from the top corner, which you and I know is difficult for me to locate with the mouse, especially when the color here does not really bring out the boxes like other places. Okay. But if you're able to zoom in on your image to the very first pixel and click on it, the value you get will correspond to the value that is here. Okay, so these are the values for the pixels. You can also call them as digital numbers. And so, yes, we have our band now. So maybe what next? I also want to do something. I will bring up PyCharm. You don't have to use PyCharm, but I just want to show you what is inside a raster data that has been read. I do so because PyCharm's debugger, I don't really know about VS Code's debugger, but the PyCharm debugger is very powerful, very, very powerful. That's what I use. And then, will this one also do it? Maybe not. Let me use the one that I know how to use. So I'll bring up PyCharm also. You don't have to do this. It's just for demonstration. And then I've opened the same folder in PyCharm. So what I'll do is to go ahead. For this one, I have to create a regular Python file. So new, and then Python file, maybe I'll call it main. Let me repeat, you don't have to do this. Okay. And then here I quickly import Rasterio. Real. Okay, and then maybe let me call data equal to, the path is data/data/dem/dem.tif. Okay. And so I can go and say with, I intentionally did not import Rasterio as real so that you can know that you can use it that way too. So rasterio.open, and what are we opening? We are opening data in read mode. You can specify, by default it is R, but there is no harm in specifying it. So as src, or let me open this one as raster so that you know that you can put a different value there also. And then here I can say maybe I want something just to put there, maybe band equal to raster dot read, and then read the first one. When I put a breakpoint here, and then I go to debug, it should bring up my PyCharm debugger for me. That is here. So let's give it a few minutes for it to connect. Sorry, a few seconds, not minutes. Okay, so it has connected. I know it's a lot of things here, a lot, just a lot. Please focus on the very simple ones here. Okay, I think we have to pass this place. Because if I exit now, it will break. So let me just introduce some dummy print statements here. So print nothing. And then let me debug again. I'm just putting the print here so that I can jump over it to another valid Python line. Okay. Once again, you don't have to do this. I'm just showing you some stuff here. And then I step over. Okay, so no such file or directory. Oh, yes, there's no such file or directory because it is inside the day7 folder. So maybe what I can do is to bring this main inside the day7 folder. Okay. Okay. Now when I debug, it will work. Step over. That cannot be possible. Dot slash. Okay, let me copy the absolute path. So usually when it happens like that, just copy path or reference and then copy the absolute path. Then I just put that one in and then be free. Okay. So it's just the absolute part of the raster. Once again, I just want you to sit back and enjoy this particular session. You don't have to open PyCharm and do this if you don't have PyCharm. But if you do have and you want to also follow, fine. Now that the file has been read properly, I don't know whether you can see it on your screen. Let me try and then still maximize. Because you look like the debuggers fonts, they are usually very small. But you can see, I think I've hit the maximum. But you can see data, which is the file that has been read here. And there's also called raster. Raster is how I read my raster data. When I open it, I see bounds. I see other things like count. The bounding box, if I expand it, has coordinates. So all of these attributes, we call them metadata. We can access it in the raster. So what makes up the raster is this, the grid, the data itself here. And then I'm looking for one particular called transform. This transform, very, very important. This one uses what we call the affine transformation. Now, I told you initially that a raster is just a grid of numbers, a grid that contains numbers that represent maybe some phenomena on the earth. So how do we then put this particular grid of numbers in a geographic space? So that is what the transformation helps us to do. So all that this transformation does, if you're wondering how the raster is placed in the geographic space, it finds its way to fall at a particular place in the earth. That is because of this transformation parameters. This is the affine transformation. You can use other transformation parameters like the polynomial transformations, maybe the first order, second order, or third order. There's also the spline transformation. There's also the helmet or the similarity transformation, piecewise linear transformation, and so many of them. But this mostly uses the affine transformation. And that contains the rotation and scaling parameters that you can use. So that tells you that, okay, this raster is supposed to be at this particular place. If you have done any form of georeferencing in any GIS software where you have a raster that you want to put in a geographic space, so you get your ground control points, and then you try to align the raster to those ground control points, all that you are doing is to find the suitable transformation parameters to put your raster in the particular proper place. One thing, we'll be using this one a lot. That is why I'm taking my time to come to this place to show you the transform, because if you are creating a raster, you should define the transformation. And then also another thing that take a look at is the profile. Yes. So it is also rasters, the rasters profile. And so we see things here like the driver, the data type, the no data value, the width of the raster, the height, and the number of bands. There is also the CRS inside that. You don't have to cram all of these things into your head. The only thing is that we'll be typing some codes to access some of these attributes and properties. And my goal is to let you understand everything I do here, not just to type and follow blindly. That is why I'm showing you that this particular data that we have read here, that we said read as raster, has all these attributes, and that is what makes it up. Okay. I know this particular PyCharm session has been a lot. Maybe you will have to rewatch this stream and then ask questions if you have to. But just know that all these attributes are there. You can access the driver and the compression type and then other things like that. Okay, so enough of PyCharm. Let's go back to our VS Code. Okay, so now we have this here as a raster. How do we see this our raster? Let me maybe we do proper plotting in tomorrow or subsequent sessions, but at least something nice to spice up today's session. Maybe today's session is just getting a little bit different from previous ones. So if you want to plot or see your raster, what you can do is that there is a plotting manager in Rasterio. So you can say from rast dot I just saw in the studio that my feed was. Please let me know Someone is saying that he cannot hear the audio also. Okay, so I think the network brought about a lot of things. Please, can you hear me now? Please, can you hear me now? The audio isn't working. Hello? Okay. So sorry about all those inconveniences. My my main network, I think it just got off, so I had to switch to the backup, and I don't really know how strong the backup can be to maintain the stream. And if I have to go and now refresh or reset my router before I connect again and come back, I'll keep you waiting for so long. It's already past the hour mark, so please let's pause here for today, and then we will continue tomorrow. See how we can um, access the particular values at particular pixels, how we can perform other amazing stuff with the Rasterio Python package. Okay, so sorry for the inconvenience today. Uh, we will get better at it tomorrow. Okay. Yes, it is working now, but the bar on my stream interface is just about 30% strength, and I can't really rely on that. So I think I'll end the stream here, and then we continue tomorrow as well. Okay. Uh, if there are any questions, as always, I will give 1 minute, then I will address it. If there are no questions, then we anticipate for tomorrow. Okay, so there are no questions. That is great also. Once again, sorry for today's inconvenience. And tomorrow, just make sure that you have at least a DEM downloaded, and then also make sure that at least you have tried this session. You first of all import it, Rasterio, and run the cell. Make sure that everything works, because it depends on GDAL, I think so. So if you have a problem with GDAL, maybe you have a problem with Rasterio. Try maybe try this line also. Try and print. Make sure that at least you can open data sets, assess the band, and maybe show it so that we know that your Rasterio is really working. Tomorrow we come, no introduction sort of stuff. We just come straight to VS Code and do the amazing things we can do with Rasterio. Okay, so once again, thank you for your time, and have a great day, all of you who are still in the day, and have a good night to all of you who have to retire to bed. And until next time, it is goodbye.